Learning outcomes. After studying this module, you shall be able to know about paper and its manufacturing. Identify different techniques that are employed in the examination of paper. Introduction. Paper is one of the important evidence in cases of forgeries and counterfeits. Paper is available in abundance in the market and is one of the most important writing surface. So, probability of finding the different types of paper in different cases of crime related to document are more. Paper is made by different processes, so it can be said that paper can be distinguished from each other on the basis of different paper, and it should be done by using scientific method which provide solid evidence in the detection of paper. Some papers are rough, some are smoother and some are lined. Some of them are plain and some of them on the texture on it. All these varieties of paper provide some sort of uniqueness to them. This uniqueness can be the basis of identification of the paper by different methods that we reveal in this module. Moving further with the topic. Most documents are based on paper and those that are not too rare to be considered here. Electronically stored information is likely to play an increasingly important part in administrative and financial activity, destined perhaps largely to replace conventional paper-based documents. The examination of these types of stored information, whether on the tape or disk or in any other form, it is not dealt with the book. These areas are not regarded to as province of the forensic document examiner. Papers, as mentioned earlier, too can be involved in many ways in many cases. These are some examples of the cases in which the analysis of paper is of utmost importance for solving the cases. First is, sometimes the date of the document is not in accordance with the date of the manufacturing of the paper. Say, if a document is available dated 12 August 1902, but on analysis of that paper, the document manufacture of the paper was found to be around 2005. Whether the paper is identical with or different form of other papers of the same document, whether the watermark of the paper is genuine or forged, whether the paper of question, receipt, agreement, compromise, etc. is a part of some other paper from which it can be torn to use signature or thumb impression, attachment thereon for some other purpose, etc. Paper is made up of cellulose fiber in the form of compact sheets with uniform thickness. In very ancient time, when India was ruled by kings, at that time leaves of plant called as Bhujapatra was used for the purpose of writing. Mahatmas and rishis used the sheets of metals for the purpose of writing. These metal sheets are known as tampatra. Papyrus plant bark used at around 3500 BC for preparation of sheets which could be used for writing. The production technologies has changed with time and recent discoveries has been made on the process of paper manufacturing, easy and less time consuming due to the increase in automation.
Manufacturing of paper. Some basic knowledge about paper development and its manufacturing. The development of mechanical paper by Keller in the year 1843 has made the paper production easier. The first chemical treatment process using calcium bisulfate got developed in 1864. In 1884, a refining process based on the use of sodium sulfate was developed by Dahl. One of the methods of paper manufacturing has already been mentioned in the previous module. There is some more information about how the paper is manufactured. Steps involved in the manufacturing of paper. Racks of linen or cotton were stored, cut up, washed with water and left to ferment in closed vessels for several weeks until a pulp mass was obtained. This was beaten in oak with stamping rods fitted with iron heads and worked either with hand or by primitive mills. The pulp was then spread evenly upon wire module, upon which was then placed a mahogany frame termed the decal and subsequently transferred to a layer of flat. After being repeatedly pressed, it was sized and given final pressing. There are number of substances which can be added to make a paper nowadays, but for our convenience, we categorize them as rag. This includes cotton, hemp, linen, etc. Wood. This include coniferous trees like pine, fir, etc. Straw fibers like rice, wheat, oats, rye, etc. The quality of paper can be improved by the addition of some sizing and loading agents which help in developing the cellular strength and required weight of the paper. General examination protocols to be followed for the paper examination. The different ways of analyzing the paper and their significance has been mentioned. First is color of the paper should be determined by comparing it from the color chart. Second, the weight of the paper should be confirmed per square meter. For common paper, the weight is approximately 1.9 to 8.7 gram square per meter. Therefore, can be a difference in limit of 2.5% only for the samples which have the common origin. The thickness of the paper can be measured by the micrometer and paper calipers. Next is the ash residue, such as cellulose, cotton, jute, sun, and diecious fibers. Composed paper have a ash residue of 0.4 to 1.5%. Pulp of straws and cellulose made paper have ash residue of 2 to 6%, and for rice paper this weight is 14 to 15%. The papers which have the common origin may have a difference of up to 4.5%. The ash residue is mostly due to presence of loading agents. Next is microscopic examination. The ratio of fibers and the distribution of these fibers throughout the paper is same in the papers of same batch. From microscopic study of paper, we can also know about the structure of fibers present in the paper. Next is character of paper. It can be determined by degree of beating and the study of the amount of the fibers. Then it is fluorescence. Two papers can be compared under ultraviolet light for the comparison of fluorescence. Next is watermark. Watermark can be seen in strong light. The size of watermark, its design, and the fluorescence it produces in the UV light. Next is loading and sizing agent. Sizing agent like rosin, starch, gelatin, aluminum hydroxide, and synthetic polymers can be used to stop feathering of ink in the paper, and hence they can be detected by careful examination of the paper. Sizing agents are also used to provide cellular strength to the paper. Loading agents are used to make paper smoother and non transparent. They are also known as the fillers. Next is coloring agent. If the paper have been colored by using some dye or pigment, then the paper can be subjected to TLC for the detection of that particular dye or pigment. Other evidences like fingerprints can also be found on the documents many times. So before doing anything on the document, it is checked for any other evidences like fingerprints and then preserved accordingly. Next is testing of paper. The methods of manufacture described give rise to differences in the end product that can be tested in the laboratory. Invaluable information can be obtained that allows different samples of paper to be compared and dated. In addition, it may be possible for the country of origin of a piece of paper to be discovered. Other techniques can determine what has happened to the paper after its manufacture and thus provide useful guidance in the investigation of crime. Some of the tests employed can be performed without damage to the specimen being tested, but others require the removal and destruction of a small part of the piece of paper. Next is non-destructive test. Most of the operations in the manufacture of paper provide features that can distinguish one type from another, either by direct observation or by more elaborated techniques. Color, shape, size, and thickness of the sheets, the watermark and lead marks from the dandy rolls, and patterns produced by the frame, and the appearance of the surface, which may be evenly colored or malted, can all be examined by simple observation and measurement. The feel of the paper, how smooth it is, or how stiff it can be ascertained by handling and by noise it makes when shaken. These apparently crude tests nevertheless have value in comparing two pieces of paper. They detect difference in makeup with a certainty as great as more sophisticated methods and have the advantage that nothing is damaged or destroyed. Next is fluorescence. When Light falls on certain compounds and is absorbed. It excites radiation at a higher wavelength. This is described as luminescence, a term that embraces both fluorescence and phosphorescence, the former term referring to an immediate effect, and the later two, one where the emitted light is delayed. Fluorescence can also be tested without change to the paper. This phenomenon of interest in many areas of document examination and other branches of forensic science depends on the absorption of light and its simultaneous emission at a different wavelength. The eye is sensitive to a range of wavelength from about 400 nanometers, which is seen as violet, to about 700 nanometer, which is seen as red. The wavelength in between are seen as the other colors of the spectrum, and a combination of all is seen as white light. Ultraviolet radiations, which as its name suggests, its radiation beyond the violet end of the visible spectrum, has a wavelength between 200 and 400 nanometer and will produce fluorescence in the visible part of the spectrum. Different substances fluoresces with different wavelengths and intensities. Under the ultraviolet lamp, some papers emit a strong luminescence, while in others it is weak or not present at all. There is a wide variety in the colors of the fluorescence excited by ultraviolet radiation by different papers, and subtle differences in shade can be easily detected. Similarly, fluorescence occurs in the infrared region when papers are excited by radiation of shorter wavelength in the visible region. This can also be used to differentiate papers. Infrared radiation has a wavelength greater than about 700 nanometer and is like ultraviolet out of the range to which the eye is sensitive. This type of fluorescence therefore cannot be seen by the eye but can be detected by photographic and electronic means. Next is destructive test. Further test can be carried out if a small amount of the paper can be removed. This may not be allowed if it is necessary for the document to remain undamaged, but the possible advantage of gaining extra information has to be weighed against the value of the document remaining intact. Usually, only small areas of paper needed to be removed to determine the fiber type, the method of pulping, the dyes present, and the inorganic elements in the paper. The first examination, known as fiber furnish, involves the breakdown of a portion of paper using water or, on occasions, dilute acid or alkali into a pulp in which the individual fibers can be examined microscopically. This enables the determination of the original method of pulp preparation, whether mechanical or chemical, to be determined and different varieties of fibers to be identified. These can be materials such as cotton, grasses, and straw, and many varieties of fibers from different species of wood. Tests can also be performed to determine the chemicals used during manufacture to prepare the pulp from shredded wood. Next is some important examination which are more specific. Appearance of paper is an important factor in the examination or study of paper. It includes important points and should be done while analyzing documents by physical method. First is all the markings on the paper should be recorded, and also the location of these marks should be noticed. The marks which should be noticed include marks like punch marks, staple marks, indentations, etc. Second, the edges of the paper should also be examined carefully, either with a low power microscope or with a magnifying glass, to determine if there are any torn edges or cut edges in the paper. Next is the dimension of the paper should also be noticed. Next, the surface texture of the paper under analysis should also be studied carefully. The number and the position of folds present, if any, should be noticed. The watermark identification is also one of the important aspect of the paper study, as it can also be forged. The following knowledge can prove good for distinguishing artificial watermark from the genuine one. In artificial watermark, the paper will not be thinner in the area of watermark, because of thinning of watermark can only be caused in the paper at the time of its manufacturing. Sometimes an artificial watermark is made by applying some acid in the appropriate area to make the paper comparatively thinner, and sometimes a watermark is made by applying some oil or grease on a metal block and pressing it against the paper to make it comparatively more translucent. In the latter case, the forgery may be detected by treating the watermark area with dilute caustic solution, which would obliterate or dim the artificial or fake watermark. Identification of the fibers present in paper pulp. The identification of the paper pulp can be done by its microscopic examination, and the conclusion can be drawn on the basis of in-depth study of fibers present, and the study should be done by an experienced scientist. The fragment of paper under analysis should be treated with 1% of sodium hydroxide. This is done by separation of the fibers of the paper. Once the fibers get separated, they are placed on the slide and then a small drop of Herzberg's reagent is added to it. This prepares the fibers on the slide for microscopic examination. The following fibers are generally used in paper industry. First is wood fibers. They are found in coniferous trees like pine, or they can also be obtained from the dioecious tree such as eucalyptus, chestnut, etc. The fibers of the wood fiber are shorter than the fibers of textile fibers, and they have a broad lamina with a wider circular orifices surrounded by bordered pits. Next is textile fibers. These fibers are generally obtained from plants like flax, hemp, and cotton, etc. Their fibers are very long and they have very narrow lumen. Next is starch fibers. They are product of plants such as rice, wheat, oats, and rye, etc. Their fibers have hair or scale like epidermal cells and cylindrical or spherical parenchyma cells. Their fibers are smaller and cylindrical. Detection of sizing agent. As many sizing agents are added to the paper for different purposes, so their detection may help us to identify the paper involved in crime. There are some of the methods which can be used to detect some of the sizing agent present in the paper. These methods are gelatin, which is one of the sizing agent in the paper, can be identified by a chemical reaction. Boil some paper strips in water and save the extract. The extract is treated with dilute solution of galotanic acid. Gelatin in the presence of galotanic acid gives rise to flocculent yellowish precipitate. Rosin is also one of the sizing agents which can be detected in the paper as follows. 1 to 2 drops of saturated solution of sucrose is added to a small piece of paper placed in a polyethylene tile. After 10 seconds, the excess solution is removed from filter paper and 1 drop of concentrated sulfuric acid is added to it. If red raspberry color appears, then rosin is present. If gelatin is absent in the paper, then casein can be identified by using Million's reagent, which is a solution of mercury in its own weight of fuming nitric acid, and then it is diluted with 2 parts of water. The production of pink color indicates casein is present. Starch can also be detected in the paper by the formation of characteristic blue color with a dilute solution of iodine.
Summary: paper is one of the important evidence in cases of forgeries and counterfeits. Paper is available in abundance in the market and is one of the most important writing surface. So, probability of finding different types of paper in different cases of crime related documents are more. The paper are made by different process, so it can be said that the paper can be distinguished from each other on the basis of different papers. It should be done by using scientific method which provide a solid evidence in the detection of paper. Some papers are rough, some are smoother and some are lined. Some of them are plain and some have texture on it. The development of mechanical paper by Keller in the year 1843 has made the paper production easier. The first chemical treatment process using the calcium bisulfate got developed in 1864. In 1884, a refining process based on the use of sodium sulfate was developed by Dell. The quality of paper can be improved by the addition of some sizing and loading agents which help in developing the cellular strength and required weight of the paper. General examination protocols to be followed for the paper examination, that is what are the different ways of analyzing paper, and their significance has been mentioned, like the color, weight, ash residue, microscopic examination, loading and sizing agents, coloring matter, fluorescence and thickness.